my name is Stefan Escaida Navarro, and currently I'm a research engineer at Inria, Lille, North Europe. I'm working in SimCardioTest use case one. One aspect of my research is the development of anatomical soft robots. So it means that we use the technology of soft robotics and the numerical simulation that is being developed at Inria to create replicas of the human organs that replicate some of the functionality. That means in the case of the SimCardioTest project, we try to replicate the functionality of the human heart. It has potential to improve medical training, and also it's important for the validation of medical devices. In the scope of the SimCardioTest project, the aim is to reduce trials on animals and humans, and to rely more on the technological means we have. So that in part is simulation, but also there's a validation that can be done using these anatomical robots. So that means that a company that fabricates medical devices can validate their devices with the help of these more advanced phantoms. In particular, the objective is to improve and to validate the design of pacing leads. The pacemaker has two main parts. One is the part that has the logic of control of the pacemaking. It's basically equipped with some kind of microcontroller and electronics that are able to provide the stimulation, the electric stimulation. And the lead is basically a device that connects this box to the place where the stimulation needs to happen. And it's basically, the lead is basically a wire to transmit the stimulation signals to the wall and the lead is highly deformable. And this is a sensitive part of the intervention is to navigate the lead towards the place where it needs to be attached on the heart. The idea is to replicate this part of the heart anatomy that is relevant, so that we can study the insertion of the lead and then the attachment of the leads to the wall of the heart. I'm dedicated to the realization of the mechanical part. I use a simulation to design the device that will work as a heart, but I also work on the part that is the concrete realization in using deformable materials and actuation methods to realize this device in the real world. So the current status of the work is that we were able to finish a very first prototype of the actuated phantom, and we used available data for heart motion to create the geometry of the heart and also find the modes of actuation necessary to reproduce the motion. And in our first results, we see that we can, with this device, we can somehow reproduce the motion of the human heart. The next step is to create a second iteration of this prototype. And in the second iteration, we will want to concretely address also the challenge of navigation of the lead. It is an important step towards improving the pipeline of the development of medical devices. The future of medicine is highly related to personalized medicine. And I think the results from the project will go in this direction, and that the procedures that will be performed on the patients will be validated in simulation and possibly on phantoms before they are performed on the real patient.